Hello, good to see you here. Today we are going to learn how to build generative AI agent with Vertex AI and Flutter. In this course, you'll learn how to develop an app using Flutter, Google Portable UI Toolkit, and integrate the app with Gemini, Google family of generative AI model. You also use Vertex AI Agent Builder, Google platform for building and managing AI agents and application. This course helps you learn about the Gemini models and their use in generative AI application. You learn about some of the tools that are available on the Vertex AI platform that are used to build search and reasoning agent capability for your Gen AI apps. You also learn about Flutter, a UI framework that is used to build applications for multiple platforms from a single code base. Let's review the course of learning objective. In the module 1, you learn about Flutter for app development, Gemini and its use in generative AI, and Vertex AI, which are the underlying frameworks and platforms that are used to build Gen AI apps. Generative AI and Gemini overview. Generative AI refers to the use of AI to create new content like text, images, music, audio, and videos. Generative AI is a type of artificial intelligence technology that can produce various types of content including text, imagery, audio, and synthetic data. It is powered by a foundation model, large AI model that can perform many tasks such as text summarization, QA, classification, translation, image generation, and more. Work by using a machine learning model to learn the patterns and relationships in a data set of human-created content. It then uses the learned patterns to generate new content. Generative AI models, the process of learning from existing content is called training, and the result in the creations of a statistical model. When given the prompt, Gen AI uses this statistical model to predict what an expected response might be, and this generates new content. Generative language model learn about patterns in language through training data. Then given some text, they predict what comes next. Generative image model produce new image using techniques like diffusion. Then given a prompt or related imagery, they transform random noise into images or generate image from prompts. Let's see some example. Here is an example of using Gemini, Google family of large language models, which are able to communicate and generate human-like text in response to a wide range of prompts and questions. So over here, there's the prompt saying that I am making a sandwich with peanut butter and then there should be some more, but that is not mentioned here. So then the Gemini responds. Do you like this response? Gemini is a family of generative AI model from Google that is designed for multi-modal use cases. So let's see some of the Gemini models. We have 6. Gemini 1.0 Pro. So every model supports different tasks. For example, the 1.0 Pro model supports a wide range of tasks using text as input. And the Gemini 1.0 Pro Vision model support text, images, and video as input for a broad range of application. Gemini 1.5 Pro multimodal model supports adding images, audio, video, and PDF files in text or chat prompts for text or code response. This model supports long context understanding up to the maximum input token limit. The 1.5 Flash multimodal support text, code, images, audio, video, and PDF data input and provide speed and efficiency for high volume, cost-effective application. Gemini 1.0 Ultra is a text model that is optimized for complex tasks, including instruction, code, and reasoning. Gemini 1.0 Ultra Vision is a multi-modal model that supports joint text, images, and video input. The Gemini models are part of a growing list of foundation models that you can test, deploy, and customize for use in your AI-based application. The models are available and accessible on Vertex AI, Google ML platform for training and deploying ML models and AI application. Next, we will review Vertex AI in the next lesson. Vertex AI overview. What is Vertex AI? a machine learning platform used to train and deploy ML models and AI application. With Vertex AI, you can use and customize large language model, including Gemini, in your AI-powered application. You can access foundation models in Model Garden, tune models using simple UI on Vertex AI Studio, or use the models in Data Science Notebook. Vertex AI combines data engineering, data science, and ML engineering workflow, enabling your teams to collaborate using a common toolset and scale your applications on Google Cloud. Benefit of using Vertex AI. Some of the benefits of using Vertex AI are here. Access to Gemini and other model. Let's expand. Vertex AI provides access to Gemini and other model where you can prompt and test them with text, images, video, or code. You can customize the model for your use case with a variety of tuning options, which helps simplify prompts and reduce the cost and latency of your requests. Next, open and integrated AI platform. Vertex AI is an open and integrated AI platform that provides data scientists with tools for training, tuning, and deploying ML models. You can reduce training time and deploy models to production easily with a choice of open source framework. ML Ops tools for predictive and generative AI. ML Ops is a set of practices that improve the stability and reliability of your ML system by keeping your model relevant with changing data and optimal performance. Vertex AI ML Ops provide modular tools to help you collaborate across AI teams and improve your models throughout the development lifecycle with predictive model monitoring, alerting, diagnosis, and actionable explanation. Vertex AI Agent Builder enables developers to easily build and deploy a generative AI experience using natural language or a code-first approach. With Vertex AI Agent Builder, you can create generative AI agents and application grounded in your organization data. Features of Vertex AI. Here are some of the Vertex AI features. Developer can build generative AI features into application by accessing Gemini and other models using API. The Vertex AI Model Garden contains a variety of first and third-party tools as well as open models such as Gemma and Llama. Vertex AI notebooks are natively integrated with BigQuery, providing a single surface across all data and AI workloads. Vertex AI Agent Builder provides a no-code agent builder console with powerful grounding, orchestration, and customization capability. In the next module, we will discuss Vertex AI Agent Builder in more detail. Flutter overview. What is a Flutter? Flutter is free open-source portable UI toolkit from Google that is used to create natively compiled applications for mobile, web, desktop from a single codebase. Flutter is powered by Dart, a language that is optimized for running apps on any platform. Flutter is an open-source framework that is supported by Google. With Flutter, you can build adaptive and responsive apps. Benefit of using Flutter. Some of the many benefits that can be gained by using Flutter for app developments are listed below. Develop and deploy apps quickly. Flutter lowers the bar to entry for building apps by accelerating app development with reduced costs and complexity of app production across platforms. Convert concept to production code with ease. Flutter provides a canvas for high-end user experience that let you easily turn concept into production code. Run apps on multiple platforms. Flutter lets you build apps for multiple platforms out of single code base, reducing the time for feature development and release update. Flutter apps can run on mobile, like Android and iOS web and desktop platform. Support a variety of platform integration and services. Flutter package ecosystem support a wide variety of platform integrations such as camera, GPS, network, and storage, and services such as payment, cloud storage, authentications, and apps. Features of Flutter. Here are some features of Flutter. Flutter doesn't rely on web browser technology nor the set of widgets that ship with each device, but instead it uses its own high-performance rendering engine to draw widgets. Flutter apps, compositing, gesture, animation, framework, widget, etc. are written in Dart, a modern, concise, object-oriented language. Flutter includes an optimized mobile-first rendering engine and a modern React-style framework with a rich set of widgets. The Flutter SDK also includes API for unit and integration tests, API connect to third-party systems and tools to create, build, and test, debug, and profile your apps. Let's look at the Flutter architecture. Flutter is a cross-platform UI toolkit that is designed to allow code reuse across operating systems such as iOS and Android, while also allowing applications to interface directly with underlying platform services. Flutter is designed as an extensible layer system. It exists as a series of independent libraries that each depends on the underlying layer. Let's look at the layer. You can click each marker to learn more. So basically, we have a framework layer, engine layer, and an embedded layer. Let's look at this one, the Flutter framework. Developers interact with Flutter through the Flutter framework, which provides a modern reactive framework written in the Dart language. It includes a rich set of platform layout and foundation library composed of a series of layers. Looking at Material and Cupertino library. So the Material and Cupertino libraries offer a comprehensive set of control that uses the widget layer composition primitive to implement the Material for iOS design language. So widgets layer is used for object of composition and is where the reactive programming model is introduced. Rendering layer is provide an abstraction for handling object layout. Foundation layer, basic foundation classes and building block service for animation, painting, and gesture. Move on to the engine layer. So the Flutter engine support the primitive necessary to support all Flutter applications. The engine provides the low-level implementations of Flutter core API, including graphic, text layout, file, network I/O, accessibility support, plug-in architecture, and a Dart runtime and compile toolchain. The engine is exposed to the Flutter framework through Dart UI, which wraps the underlying engine code in the Dart classes. This library exposes the lowest level primitives such as classes for driving input, graphic, and text rendering subsystem. The last layer, embedder, platform-specific. A platform-specific embedder coordinates with the underlying operating system for access to services like rendering, surface, accessibility, input, and manage the message event loop. The structure of Flutter app. Here is an overview of the piece that make up regular Flutter app. It shows where the Flutter engine sits in this stack and highlight the API boundary. So Dart app compose widgets into desired UI, implement business logic is owned by app developer. Flutter framework provide a high-level API to build apps, for example, use widgets, heat testing, gesture detection, accessibility, and text input. Composite the app widget tree into a scene. Move on to Flutter engine is responsible for rasterizing composite scene, provides low-level implementations of Flutter core API, for example, graphic text layout and Dart runtime. Exposes its functionality to the framework using the Dart UI app. Integrates with a specific platform using the engine embedder API. Next, go to the embedder layer. So embedder coordinate with the underlying operating system, access to service like rendering, surface, accessibility, and input. Manages the event loop, expose platform services API to integrate the embedder into an apps. Finally, the runner compose the pieces exposed by the platform-specific API of the embedder into an app package that is runnable on the target platform. It's part of the app template that is generated by Flutter Create. It's owned by app developer. So the Flutter concept. As a Flutter app developer, here are a few concepts of the UI framework to be aware of when developing your apps. Flutter is a reactive, declarative UI framework where the developer provides a mapping from the application state to the interface state. Flutter explicitly decouples the user interface from its underlying state. You will only create the UI description, and the framework uses that configuration to both create and or update the user interface as appropriate. The framework updates the interface at runtime where the application state changes. In a Flutter, you create widgets represented by immutable classes that are used to configure a tree of objects. Widgets are the building block of a Flutter app user interface. Apps update their user interface in response to events such as user interaction by telling the framework to replace a widget in the hierarchy with another widget. The framework that compare the new and old widgets and efficiently update the user interface. Number 6. During development, Flutter apps run in a virtual machine that offers state halt, reload, or changes without needing for a full recompile. For release, Flutter apps are compiled directly to machine code or to JavaScript for the web. Number 7. Flutter apps can also be embedded into existing apps, whether they are mobile or web. Developing a Flutter app. What is the process? So first you set up your Flutter environment. You can choose any editor to develop your app. The famous one will be Visual Studio Code, IntelliJ, Vim, etc. You choose a development target. Flutter is a multi-platform toolkit that enables your app to run on multiple operating systems like iOS, Android, Windows, Mac OS, Linux, and web. Choose an operating system for which you primarily develop. This will be your development target, the OS that your app run on during development. Step 2. Install Flutter and required tools. So these are the prerequisites. So you need to download the Flutter SDK distribution and then create a folder to install the SDK. Then unzip the distribution in the installation folder and add the Flutter install folder path into your environment variable path. Configure your operating system for development. That is the step 3 now. So after installing the required tools for your development target operating system, you may need to configure them before starting with the app development. For example, Mac OS, you have to configure Xcode, configure a physical OS or iOS simulator to run your app. Number 4, step 4, check your development setup. To verify the installation of all the components, you can run the command called $Flutter Doctor. If the command output indicates there are issues with your setup, you can rerun the command with the verbose option. That is, you put a -v at the back. And then step 5, you can create a Flutter project. From your IDE of the command line, you can create a new Flutter application project, add code to the library main.file, file, which is the entry point of your Flutter app. And summary, with all the prerequisites and the Flutter SDK installed, you can start developing your Flutter apps. Quiz time. Well, you can go through the quiz. The passing score is 80%. So the first one is, what are some ways to describe generative AI? Select 3. Question 2, what are some features of Vertex AI? Select 3. Number 3. Question 3, which statements about Flutters are correct? Also select 3. Question 4, which statement regarding Gemini models are correct? Select 2. So the answer will be listed in the description. Thank you. With that, we have finished the first part, Flutter, Gemini, and Vertex AI.